Hi everyone. Thank you so much for coming today. My name is Kyra Tan. I'm currently a senior, and my project is about reducing accidental poisoning with biosonic hazing for plovers. And my mentor is the wonderful Beth Lintz, who I'm so lucky to have with me here today. And my teacher for independent research is Dr. Chan, and she's been so amazing and supportive on this journey. So I just wanted to start off at Sand Island. And this is Sand Island. It's part of the Midway National Wildlife Refuge. And it's part of the Northwestern Hawaiian Islands. And it has an excellent rating of 4.4 stars on Google Maps, but unfortunately there's no way to get there easily. But part of the reason that this island is so great is because it's isolated, and that makes it a great breeding ground for many shoreline birds and seabirds. And the island is about 1,300 acres and is home to various endangered species, including the Laysan albatross, where about 70% of its population stays during their breeding months. Unfortunately, there is a problem on Sand Island. Currently, there's an invasive mouse population that has been attacking the Laysan albatross, and we don't know exactly why. It could just be because Sand Island is such a produces so little food for the mice, and they might be attacking the albatrosses because of that. But besides the point, it's resulted in about 250 dead late albatrosses and about 1,200 injured adults in just the span of a year. So this is something that is obviously very concerning for the bird population there and the researchers who are studying these birds. So a proposed plan by the Fish and Wildlife Service has been basically to apply rodenticide to the island during the summer months when most of the birds are migrating. And this would basically help to eradicate the mouse population and hopefully eliminate this problem of the birds being attacked by the mice. But there are some concerns that this project has, specifically for the effects of the poison on other shoreline birds. And most of the population of these birds migrate during the summer months to Alaska, just as their summer grounds. But because sometimes, for whatever reason, sometimes individuals such as juveniles who are in their first year and aren't ready to migrate, or adults for whatever reason just don't migrate, there is a marginal percentage of the population that stays behind during the summer months and could be exposed to the rodenticide. So based off of other islands that have had rodenticide applied to them in hopes of rodent eradication, the Fish and Wildlife Service has totaled that in the worst case scenario, which would be defined as the rodenticide birdificam during the application period of a couple months in the summer, in addition to the effects through the year, because the rodenticide can remain in the environment and be intaken through secondary sources such as the birds eating a food source, like a crustacean that has ingested the poison. Death counts for these different species of birds could be as high as about 700 birds for the golden plover, or as we're more familiar with it, the colea, about 200 birds for the ruddy turnstone, about 70 birds for the bristle-thighed curlew, and about 20 watering tattlers. And as far as their global population goes, that these numbers or potential death counts aren't very concerning because they have a much larger population. But in terms of the specific ecosystem at Sand Island, this could be very significant in the change of just the number of birds. And specifically for the bristle-thighed curlew, where about 70 birds would be possibly half of the population on the island. So this is where I come in this mouse plan, is I hope that I can reduce the shoreline bird presence and basically reduce their exposure to the poison. And the way that I focused on doing this is basically looking for ways to scare the birds or haze the birds to other islands. And there's other islands like the Eastern Island that researchers are hoping that the birds will go to instead of Sand Island, and they'll provide additional supplies and food for the birds there so that they can support themselves during these months. So some of the audio deterrent options that I explored were things just a lot of them are very commonly found in the market, such as bird bangers, which are just general shooting blanks. And there's also things like white noise machines. And these have been used a lot commercially just to deter birds from urban areas. and sometimes agricultural areas, but they've been found to not have great habituation periods, which means that the birds tend to get very used to these things quickly unless they're paired with some kind of physical damage, such as shooting, which obviously is not great in this scenario. And then there's also more specific deterrents, such as ultrasonic frequencies, which are just high frequencies that humans can't hear, but birds can hear and find annoying. And there's also similar issues with applying that to this scenario because, again, the habituation periods based off of other studies wasn't great for most bird species. And additionally, both of these methods, so to speak, could change how like the rodents are affected. Like some studies found that rats and mice actually stopped eating or ate less when they were exposed to ultrasonic frequencies, and that could potentially damage the outcomes or the effectiveness of the eradication plan. So the audio deterrent that I settled on was biosonic deterrents. And what's great about biosonic deterrents is that they can become species specific because essentially you're just using animal noises to affect a population's behavior. And in my case, I wanted to use like alarm calls, distress calls from these specific birds to scare them away from the island. And the great thing about that is that it doesn't affect other species, so you can hone in on just the birds and not the mice. And it's also a relatively cost and labor efficient way to do things because sound just naturally covers a broader area and doesn't take too much physical things to implement. So the way I tested the biosonic deterrents was actually just here on Iolani's campus. And essentially what I did for my experimental group is I just looped together soundtracks of Kalea alarm calls that I found online, and then I played them on a speaker outside on Iolani's baseball and football field. And I just observed how much time the Kalea spent at each site, and compared that to my control group, which is basically birds just doing their own thing without me disturbing them. And I weighed the amount of time that they spent at the sites versus the amount of time they spent away from the site, and then divided the two groups just on whether they were exposed to the deterrents or not exposed to the deterrents. Oh wait, sorry. And I'll play a little sample of the deterrent that I used for them, just to give you an idea of what it sounds like. So that's pretty much just like the Kalea's alarm call. And then I have a short clip of the Kalea's reacting to the alarm call. And for the most part, sorry, the audio's not quite loud, but for the most part, they would stop their like feeding behavior and they would just stand around and sometimes look at each other and bob their head trying to verify the source of the sound, or sometimes have investigative behavior, but usually they would leave the site within the first 10 minutes of me starting to play the alarm calls. So this is kind of a sample of my data. So the first graph that we see here are basically my control group, and this is just how much time the birds spend at the site without the deterrents playing. And those birds spend about 90% of their time at the site, whereas the birds in my experimental group, they spent only about 14% of their time when the deterrents were playing. And that was actually 76% decrease in the plover presence. And I was lucky enough to have a large sample size of 43 birds over 36 bird hours, which is just the total amount of time I spent observing birds. And this sample size was able to give me a statistically significant result. You can see my two-sample t-test here that verifies that. And I collected my data over a period of about, I want to say 3 months, I think from the end of October to about the beginning of December. Yeah. So contributing to that is that there's differences between the possible results that I saw and what could occur at Sand Island if these methods were implicated. So like I said, I did these during the winter months. There could be possible weather changes between the winter and summer months versus also just Oahu's climate and Sand Island's climate. The other things that have to go into consideration are that the birds here at Iolani's campus are very used to human exposure. The birds on the baseball and football field, there's PE classes and lawnmowers and sports teams that go by, and the birds hardly bat an eye. I was actually kind of questioning whether they would react to these deterrents at all since they seem so unfazed by human activity. But they did react, but there's other things to consider too, such as the population here at Iolani is very much like adult birds. There aren't that many juveniles, whereas the population that we're concerned with at Sand Island is a juvenile population. And some studies on birds suggest that like juveniles tend to be less fearful and less like flighty than adult species. So that could also have a way in the effects, say like juvenile birds don't find these distress calls as distressing as adults and might not fly away. So that kind of leads into the further research part, where hopefully we would get a chance to actually test these methods at Sand Island. And maybe if they do have similar results and decrease the amount of birds that are on the island, we could, basically duplicate this method and apply it to the other species and see if they have similar reactions to this biosonic deterrent. And there's other routes that we could go on if we wanted to stray away from deterrence. We could possibly look at things to try to aggregate birds in one area. One thing that we're hoping to start looking at is if we can use like roosting calls, per se, to try to draw calays into one area and then hopefully like capture them with the physical means like a net gun or something like that, and then relocate them to an island and hopefully put them in an aviary or something like that. Yeah. But yeah, I just have to say thank you to my amazing mentor, Miss Beth Flint, who's right here, and my wonderful independent research teacher, Dr. Chan, who's guided me through all the bumps in the road on this journey. I'd also like to say thanks to my mom and dad and my wonderful classmates for all the love and support. And I guess if anyone's interested in doing independent research maybe this coming year or in your high school career, I would definitely recommend it. It's one of the most interesting and fun classes that I've taken in high school. And I think that going into my classes, I didn't necessarily have a set project that I wanted to do. I didn't know exactly what I wanted to do, and it's fine if you do or don't, but I think as long as you have a passion for something that you want to explore and you want to learn how to design a project and read papers and maybe even gain lab or field experience, it's a great way to do all of that and also like contribute to the scientific community. And I think when I was going into this, I was thinking, how much can I actually do, because I'm just a high schooler and there's obviously I can't cure cancer by myself, but I guess it's the big results that you see in the headlines, they're just an accumulation of little solutions. And I hope that my project is just the start of a solution, but I hope that it can contribute to a bigger solution. Yeah. Thank you.